going to work with the Pythagorean theorem again. Remember that it's a squared plus b squared equals c squared. We have two legs, which is the a and the b, and the hypotenuse, which is the c. So now we're going to look at three numbers and see if it's a right triangle or not. How we do that is first we need to determine our sides. So what's my a, what's my b, and what's my c? And then I'm going to see if it works or not. So I'm going to plug it into the equation and see if each side equals each other. So I know my a is my smallest number because that's my shortest leg. So my smallest number is 3, so I put 3 squared. Then I know my b is that middle number, so I'll put the 4 in the b spot. And my c, my hypotenuse, is the longest line, which is the biggest number. Now I'm going to draw a line down my equal sign to stay nice and organized, and I'm going to do what the equation tells me to do. So I'm going to do 3 squared plus 4 squared and see if it equals 5 squared. So remember, when I square a number, it's telling me that number times itself. So 3 times 3 is 9, plus 4 times 4, which is 16, equals 5 times 5, which is 25. So now let's see if these actually do add up to get 25. And you know what? 9 plus 16 is 25. So this right here is a right triangle. So I'm going to just write yes. So let's do one more example. I've got a new set of numbers. So my first step is I'm going to determine the sides. I know my a is my smallest and my c is going to be my longest. So I'm going to go ahead and plug it in. 1 squared plus 2 squared equals 3 squared. Draw that line down the equal sign to help you stay nice and organized. Do what the equation tells you. 1 times 1 is 1, plus 2 times 2 is 4, equals 3 times 3, which is 9. 4 plus 1 is 5. Uh-oh. 5 does not equal 9, so this is not a right triangle. So I'm going to write no. This is not a right triangle.